So let us have some more problems. So we are asked here to integrate 12x cubed plus 2x plus square root of 3 dx. If they are independent terms of x, just power of x. You just use power formula. So this is going to be equal to 12, the constant, integral of x cubed by the power formula. Remember that integral of u to the n du is u to the n plus 1 over n plus 1. This is what we are going to use for this expression. So this, I repeat, is called the power formula. So this is going to be integral of x cubed is x to the 4th over 4 plus 2, this is x to the 1. Integral of x to the 1 is x to the 2 over 2 plus square root of 3 integral of dx, that is x. So integral of dx, integral is antiderivative of derivative. Okay? So that leaves you x. So simplifying further, you'll get here 12 over 4, 3 x to the 4th plus x squared plus square root of 3 x. Don't forget, because there is no limit or there are no limits, so don't forget the constant of integration c. You follow? What about this one? Product of linear terms. So what you are going to do here is you expand this first. So this is going to be 3x times 4x. This is the same as integral of 12x squared. So the one with x, so you have 3x times minus 3, that is minus 9x. 4x times 2, 8x. 8x minus 9x, that is minus x, right? And then the constant, 2 times minus 3 minus 6 dx. You get it? Or let me do it one by one for you. So it is the same as 2 times 4x, that is 8x. So 2 times minus 3, that is minus 6. Then let me distribute the 3x. 3x times 4x, that is 12x squared. 3x times minus 3, that is minus 9x. So I have here 12x squared minus 9x plus 8x, that is minus x, then minus 6. You follow? Okay. So integral of 12x squared, so these are independent power of x. So this is going to be 12 integral of x squared, x cubed over 3 minus integral of x to the 1, that is x 1 plus 1, 2 over 2 minus 6 integral of dx, x. So this is plus c. So you just simplify 12 over 3, this is 4, x cubed minus 1 half of x squared minus 6x plus c. So this is going to be the integral of this one. Okay? What about this one? Now take note that this is x plus 2 cubed. So if we expand this, this would be cubic, third degree. This is second degree, so that numerator is higher in degree than the denominator, right? If the numerator is higher in degree than the denominator, then you first divide. But first we expand this. Now, x plus 2 cubed, to expand a binomial, we just use the Pascal's triangle, or you learn from your algebra the binomial formula. But since we will be fully expanding this, the Pascal's triangle will be a lot easier, okay? So, using the Pascal's triangle, 1, 1, 1, 1, 1 plus 1, 2, 1. 1 plus 2, 3, 3, 1, and 1. This is third degree, no? So when you expand, there will be 4 terms. 1, 2, 3, 4. So this would be our coefficients. So let me expand this. So it will be x and 2, x and 2, x and 2, x and 2, right? I just wrote the 2 terms, the first, the second term. Then I add the exponents 3, 2, 1, 0. X to the 0 is 1. Then I add the exponent to 2, backwards 3, 2, 1, 0. 2 to the 0 is 1. Then I add the coefficients 1, 3, 3, 1. So since this is plus, all terms will be plus. If this is minus, this would be plus, minus, plus, minus, alternating sign. You follow? Okay. So therefore, this is going to be the same as x cubed plus 3 times 2, 6x squared, plus 4 times 3, 12x, plus 2 cubed is 8, right? So this expression is the same as this one, okay? So dividing this now by 3x squared, let me write it here. So you have x cubed plus 6x squared plus 12x plus 8 divided by 3x squared. So I will have here x cubed over x squared, that is x over 3, plus 6 over 3, that is 2, x squared over x squared, cancelled, right? So plus 12 over 3, 4. X over x squared, x to the 1 over x to the 2 is x to the 1 minus 2. Remember the rule of exponent? I will write the rule of exponent here. X to the m over x to the n is x to the m minus n, right? So you have here 1 minus 2, that's minus 1, plus 8 over 3x squared is 8 over 3. X to the 0, this is understood to be x to the 0. So 8 is the same as 8x to the 0. X to the 0 is 1. Okay? So x to the 0 over x squared, 0 minus 2, that is x to the minus 2. You follow? Okay. Now remember the limitation of the power formula. The power formula doesn't apply if n is equal to -1, no? So in here, n should not be equal to -1. Any number will do but not -1. If n is -1, this will be expressed in terms of du over u. You follow? Okay. So therefore you have here integral of this is going to be equal to the integral of this over this is x over 3 or 1/3 of x plus 2 plus 4, let me write it over x plus 1/3 of x to the minus 2 dx. Notice that this one I wrote in this form. Okay? So these are independent expressions and power of x. So we use power formula except for this term. Okay? Where we will use ln. So this is going to be integral of x over 3. We factor out the 1/3 first. This is the same as 1/3 of x. integral of x or x to the 1 is x to the 1 plus 1, 2 over 2. You just increase the exponent by 1, no? Plus 2 integral of dx, that's x. Plus 4 integral of dx over x. Remember, integral of 4 over x dx is the same as 4 integral of dx over x. Right? So that would be integral of dx over x, ln of x. Okay? 4 ln of x plus 8 over 3 integral of x to the minus 2 is minus 2 plus 1 minus 1 over minus 1 plus c, right? So we simplify, this is 3 times 2, 6. So this is 1, 6 x squared plus 2x plus 4 ln of x minus 1, 8/3 over minus 1 is minus 8/3. X to the minus 1 is also 1 over x plus c. So this is your integral for this one. You get it? What about this one? So again, there is just an exponent. All you need to do is expand first. So this is squared. So there will be 3 terms in the expansion. It will be the square of the first. So this is x to the 5 halves squared minus, copy the middle sign, twice their product, x to the 5 halves times 3x plus the square of the second, 3x squared. So this is the expansion. So squared or dx. So simplifying first before we integrate, this is the same as integral of x to the 5 halves squared. So 5 halves, 5 over 2 times 2. So this is x to the 5. When you raise a certain power to another power, you just multiply the exponent. Okay? So x to the 5th minus 2 times 3, you'll have 6. X to the 5 halves times x to the 1, this is different. This is x to the 5 halves raised to 2. So that is x to the 5 halves times 2. This one is x to the 5 halves times x to the 1. Multiplication of power of x. Remember that x to the m times x to the n is x to the m plus n. X to the m raised to n is x to the m times n. Right? So, this one is this category. This one is this category. You follow? So, this is going to be x to the 5 halves plus 1. The shortcut, when you add 1 to a fraction, so 5 plus 2, 7 over 2. So 5 halves plus 1 is 7 halves. So plus 3 squared is 9, x squared, dx. We are now ready to integrate. So because these are independent powers of x. So integral of x to the 5th is x to the 6 over 6 minus 6. Integral of x to the 7 halves is x to the 7 halves plus 1, that is 9 halves. Or 7 plus 2, 9 over 2. Over 9 halves. Plus 9 integral of x squared is x to the 3 over 3. Okay? Plus c. So this is going to be equal to 1/6 of x to the 6 minus 2 times 6, 12 over 9. Or I can simplify, divide both by 3. 6 over 3 is 2 times 2, 4. 9 over 3. So, divide by 3. This becomes 2. This becomes 3. Okay? 6 divided by 3, 2. 9 divided by 3, 3. So, this is 2 times 2, 4 over 3 x to the 9 halves plus 9 over 3, 3x cubed plus c. This is your integral. You follow? Now, we have here independent powers of x, but the problem is they are all inside a square root symbol or a radical symbol. Okay? So, how do we handle it? Most likely, the expression inside can be or contain perfect square binomial. So, look. 4, 8, 4. 4 is factorable, right? So, this is the same as square root of, let us factor out 4. X to the 1/2 is common, right? So, we factor out the lowest power of x, that is x to the 1/2. So, 4 divided by 4, nothing will be left here. X to the 1/2, we factor this out. So, this is just 1. Plus, 8 divided by 4, this is 2, so that 4 times 2 is 8. X to the 3/2, we factored out x to the 1/2, so that is x to the 3/2 minus 1/2. Okay? So that is x to the 3/2 minus 1/2. That is going to be 3/2 minus 1/2. 2 halves. Diba? 2 halves. 3/2 minus 1/2. So this is 2 halves, or that is 1. You follow? Now, plus 4 divided by 4, 1. This is just 1, no? Okay? When you factor out, it's just like dividing. So, 4 divided by 4, that is 1. X to the 5/2 over x to the 1/2. So, that is 5/2 minus 1/2. So, x to the 5/2 over x to the 1/2. It is going to be x to the 5/2 minus 1/2. So, this is the same as x to the 5 minus 1, 4 over 2, or this is x squared. Why do we divide? Because of this. We divide because when we bring this in, for example, 4x times 1, 4x to the 1/2. 4x to the 1/2 times x, that is 1/2 plus 1, 3/2. 4 times x squared, 4 times x to the 1/2 times x squared is 4. X to the 1/2 times x to the 2 is 1/2 plus 2, that is 5/2. So, in factoring out, we just divide to get the result inside. In order to expand this, we bring inside. Now, take note that this is a perfect square. I will not write 1 anymore here, right? Why? How did I know that it is a perfect square? Because the square root of 1, you take the square root of that, is 1. The square root of x squared is x. Now, twice their product, 2 times 1 times x, is the middle term. If the middle term is twice the product of the square root of the two other terms, that is a perfect square. So, we can take the square root of them individually, no? Let me first simplify further. This is the square root of 4x to the 1/2. This is the same as 1, the square root of 1, the square root of x, copy the middle sign, plus x squared. You expand this. It would be 1 squared plus x squared plus twice the product, 2x. You get it? So, this is square root dx. We get the square root of individual term. So, this would be the same as integral of square root of 4, 2. Square root of x to the 1/2, square root of x to the 1/2 is the same as x to the 1/2 square root is the same as power raised to 1/2. So this belongs to x to the m to the n, x to the mn. This is x to the 1/2 times 1/2, 1/4. This is the same as x to the 1/4 multiplied by square root of 1 plus x squared. What is the square root of 1 plus x squared? Square root and squared cancel each other out, right? So this is the same as 1 plus x. It is so because this is the same, following the logic of this is the same also as 1 plus x squared. Square root is the same as power of 1/2. 2 times 1/2 is 1. So this becomes 1 plus x. You get it? Or the shortcut, the square root and squared cancel each other out. Okay? So that eliminates the square root and eliminate the squared. Okay? So this is the same as 1 plus x. This would be dx. This is still a product. So let us bring in this one inside now. So this is the same as integral of 2x to the 1/4 times 1, 2x to the 1/4 plus 2x to the 1/4 times x, that is 2, x to the 1/4 times x to the 1, x to the m times x to the n, x to the m plus n. 1/4 plus 1, that is going to be x to the 5/4. Or when you add 1 to an exponent, you just add the numerator and denominator. 1 plus 4, 5 over 4. You get it? So multiplied by dx. These are now independent powers of x, ready for integration. Integral of this is 2. Integral of x to the 1/4, x to the 1/4 plus 1, 5/4 over 5/4 plus 2, integral of x to the 5/4, that is x to the 5/4 plus 1, that is 9/4. 5 plus 4, 9 over 4. Okay? Over 9/4 plus, don't forget, c. So, therefore, we have here 4 times 2, 8/5 of x to the 5/4 plus 4 times 2, 8, 9 of x to the 9/4 plus c. This is now the integral of this one. You get it? Okay. This one contains independent powers of x except that they are in the denominator. So it's not a problem because what we will just use is, like for example this one, 1 over x to the m is the same as x to the 0. X to the 0 is 1 over x to the m. By power of exponent or property of exponent, this is x to the 0 minus m. It's minus m. When you bring up a denominator to make it a numerator, you just reverse the sign of the exponent. So this is the same as integral of 3x to the minus 5/2 minus 4 x to the minus 3 dx. So these are now independent powers of x. So we just apply power formula. So we integrate this now. This is 3 integral of x to the minus 5/2. This is going to be x to the minus 5/2 plus 1. That is minus 3/2. Okay? This time, if it is negative and you add 1, you subtract the denominator from the numerator. 5 minus 2, 3/2. But it will be negative. So, over minus 3/2. Okay? Minus 4 x to the minus 3, it would be minus 3 plus 1 minus 2 over minus 2. Don't forget C. 3 and 3 will cancel. 2 over negative. So it's negative 2 x to the minus 3 halves. Minus 4 over minus 2, that is plus 2 x to the minus 2 plus C. So we bring it back to the positive exponent. This time we bring it down. So minus 2 over x to the 3 halves plus 2 over x squared. So when you bring it down, reverse the sign. It will become from negative to positive, from negative to positive, plus C. So this is going to be the integral. Okay? What about this one? So again, when you have binomial to a certain power, all you need to do is expand it first. So by binomial expansion, this is just the square of a binomial. So this is going to be, I will convert this to exponential form. Square root of y is the same as y to the 1/2. So expanding this should be square of the first, that is y to the 1/3. This is the same as cube root of y is the same as y to the 1/3. So the square of the first, copy the middle sign, minus twice their product, y to the 1/3, this one, times 1, the negative sign is already here, plus square of the second. So that is minus 1 squared. Okay? So dy. We now simplify. This is going to be integral of y to the 1/2 times y to the 1/3 squared. Again, property of exponent, x to the m to the n is x to the mn. Y to the 1/3 to the 2 is 1/3 times 2, y to the 2/3, minus 2 y to the 1/3 plus minus 1 squared is plus 1 dy. We bring this in. Take note that x to the m times x to the n is x to the m plus n. We add the exponent. Okay? So y to the 1/2 times y to the 2/3, we bring this inside. So y to the 1/2 times y to the 2/3, it's going to be 1/2 plus 2/3. So y to the 1/2 times y to the 2/3 is 1/2 plus 2/3. So this is going to be 7/6 minus y to the 1/2 times y to the 1/3. So this is going to be y to the 1/2 plus 1/3. This is 5/6 plus y to the 1/2 times 1, that is y to the 1/2 dy. Or in as much as you are allowed to use calculator, you just use calculator here if you are confused. So 1/2 plus 2/3, 7/6. Right? So calculate that. Okay? Well, this one, 1/2 plus 1/3, so that is 5/6. And y to the 1/2 times 1, y to the 1/2. So these are now independent powers of y. We now integrate. Integral of y to the 7/6 is y to the 7/6 plus 1, that is going to be 13 over 6 over 13 over 6 minus 2 integral of y to the 5/6 is y to the 5/6 plus 1, that is 11/6 over 11/6. So, if you're wondering here, please view the previous video of this. So, the previous lecture, so you'll understand. Anyway, just for the sake of first-time viewers, okay? So, this is when you have A over B over C. So, when you are dividing by fraction, you reverse the fraction. So, this is A times, you reverse this, C over B. So, it is the same as A over B over C. You get it? Okay, so that explains here. Over 11 over 6. You get it? Okay. So, plus integral of y to the 1/2 is y to the 1/2 plus 1, 3/2 over 3/2. Don't forget, plus c. We just simplify, that is going to be equal to 6 over 13 y to the 13 over 6 minus 2 times 6 is 12 over 11 y to the 11 over 6 plus 2/3 y to the 3/2 plus c. So this is going to be the integral. Okay? Do you follow? What about if instead of multiplication, this is division? How do we handle it? We handle it this way. So this is squared. This is square root of y. When we expand this, it is the same as this one, right? So this is going to be the same as, let me just copy the expansion here. So integral of y to the 2/3 minus 2 y to the 1/3 plus 1 over y, square root of y is y to the 1/2 dy. Instead of distributing inside, you divide each of them by y to the 1/2. Here, we bring it in by multiplying every term by y to the 1/2. Here, we divide everything by y to the 1/2. So this is going to be, remember when we divide x to the m over x to the n is x to the m minus n. Okay? So this is going to be the integral of y to the 2/3 over y to the 1/2, 2/3 minus 1/2. So this is going to be equal to y to the 2/3 minus 1/2, 1/6 minus 2. So y to the 1/3 over y to the 1/2, y to the 1/3 minus 1/2, that is minus 1/6 plus 1 over y to the 1/2 is the same as y to the minus 1/2, right? 1 over x to the m is the same as x to the minus m. You just bring up, reverse the sign. Okay? So this is dy. These are independent powers of y. So we just apply power formula. So this is going to be integral of this is y to the 1/6 plus 1, 7/6 over 7/6 minus 2. Integral of this is y to the minus 1/6 plus 1. So this is going to be plus 5/6 over 5/6 plus y to the minus 1/2 integral minus 1/2 plus 1, positive 1/2 over 1/2 plus c. We just simplify. So this is going to be 6 over 7 y to the 7/6 minus 2 times 6, 12 over 5 y to the 5/6 plus 2 y to the 1/2 plus c. So this will be your integral. Do you follow? What about this number 41? So both of them contains over 5. So let us first simplify by letting y to be x to the 1/5. So if x to the 1/5 is y, x to the 1/5 to the 4 is x to the 4/5, right? 1/5 times 4, 4/5. So this is going to be y to the 4. So therefore, we will have here, this would be y to the 4th minus 16 over y to the 1 plus 2. So, if the numerator is of higher degree than the denominator, what do? We divide. So, we divide this y to the fourth minus 16 divided by y plus 2. Y to the fourth over y cubed. Y cubed times y plus 2. So, you have y to the fourth, y cubed times 2. That would be 2y cubed. We subtract. We will bring down 16 later, huh? So, we subtract. This would be y to the fourth minus y to the fourth cancelled. So, this is going to be minus 2y cubed. So, minus 2y cubed over y, that is minus 2y squared. Minus 2y squared times y, minus 2y cubed, minus 2y squared times 2, minus 4y squared. We now subtract again. This will cancel. Minus minus, so plus 4y squared. 4y squared divided by y plus 2, that would be 4y. 4y squared over y is 4y. 4y times y, 4y squared, 4y times 2, that would be 8y. We now subtract again. This minus this cancels out. So this would be minus 8y. Minus 8y over 8, that is minus 8. Minus 8 times y, minus 8y. Minus 8 times 2, that is minus 16, right? Correct? So we now subtract minus 8y minus 8y minus 16. So let me put this aligned here, minus 16. So I have y to the fourth minus 16. Minus 16 minus minus 16, this will cancel out, so this is 0. So therefore, this divided by this is going to be this one. So this is going to be y cubed minus 2y squared plus 4y minus 8. You get it? Okay. So in here, this one, you will have here expressing this in terms of x to the 1/5. Y is x to the 1/5. So this now, the integral becomes integral of this over this. In terms of x, this is x to the 3/5. This is x to the 1/5 to the 3/5 minus 2 x to the 2/5 plus 4 y is x to the 1/5 minus 8 dx. This is now independent powers of x. We apply power formula. Okay? So this is going to be integral of this, x to the 3/5 plus 1, that is 8/5 over 8/5. Minus 2 integral of x to the 2/5 is x to the 2/5 plus 1, that is 7/5 over 7/5 plus 4 integral of x to the 1/5 is x to the 1/5 plus 1, 6/5 over 6/5 minus 8 integral of dx, that is x plus c. We now simplify. This is going to be 5/8 of x to the 8 over 5 minus 2 times 5, 10 over 7, x to the 7 over 5 plus, divide both by 2, this becomes 2, this becomes 3. 2 times 5, 10 over 3, x to the 6 over 5 minus 8x plus c. So therefore, this is going to be your integral. Do you get it? I really recommend you all of this after viewing. Please solve on your own without the video. You get it? So that you will be exposed to solving problems. Mathematics is not learned by reading, or it is not learned by listening to a lecture. It is just like swimming. You don't learn swimming by reading a book or listening to an instructor how to swim. You learn swimming by diving into water. You follow? And practice what the instructor taught you. You get it? What about this one? So, as I told you always, if it is a product of two expressions, you bring in first the other. So, this is the same as 1 over x. So, 1 over x times this. So, we bring it in. So, this is the same as 1 over, this is x to the 1/2 times 1 over x minus 2. Square root of x is x to the 1/2 times 1 over x, so over x, dx. We now simplify. This is the same as integral of 1 times 1, 1, x to the 1/2 times x to the 1 is x to the 1/2 plus 1, that is 3/2. Minus 2, x to the 1/2 over x to the 1, that is x to the 1/2 minus 1 minus 1/2. Okay? So this is dx. So let's make this a numerator by reversing the sign of the exponent. So this is the same as integral of x to the minus 3/2 minus 2 x to the minus 1/2 dx. These are now independent powers of x. So, integral of x to the minus 3/2 is x to the minus 3/2 plus 1. So, minus 3 plus 2, minus 1/2 over minus 1/2. Minus 2, integral of x to the minus 1/2, that is x to the minus 1/2 plus 1, that is positive 1/2. Or minus 1 plus 2, positive 1 over 2. Over 1/2. Over 1/2. Okay? Plus c. We now simplify. So this is going to be 2 over negative 1, negative 2, x to the minus 1/2 minus 4 x to the 1/2 plus c. You get it? Okay. So this is going to be your answer. Okay? You follow? What about this one? We're asked to integrate this definite integrals because there are limits. So take note that this is neither odd nor even. No? It is a mix of odd and even. So we cannot apply the odd-even rule for integration of definite integrals. So we are asked to solve this manually. So let's do it. So since these are already independent powers of x, ready for integration. So this is going to be equal to 12 integral of x cubed, x to the 3 plus 1, 4 over 4 plus 3 integral of x squared, 2 plus 1, 3 over 3 plus 6 integral of x to the 1, that is x squared over 2 plus 3 integral of dx, that is 3x. You don't add c because there are limits. Instead, you evaluate this from minus 2 to 2. So we first simplify this. This is going to be 12 over 4, 3x to the 4th. 3 over 3, this is x cubed, 6 over 2, 3x squared plus 3x. This is from minus 2 to 2. So substituting the upper limit for all x's, this is going to be 3 times 2 to the 4th plus 2 to the third plus 3 times 2 squared plus 3 times 2 minus, you substitute minus 2, the lower limit for x, so this is 3 times minus 2 to the fourth plus minus 2 cube plus 3 times minus 2 squared plus 3 times minus 2. Okay? So notice, minus 2 to the fourth minus to the even exponent is still the same as positive 2 to the fourth. So this minus this will cancel. Minus 2 squared is 4. That is the same as 2 squared. So this and this are the same. So you subtract, they will cancel out, right? So while this one will be different, 8 minus minus 8, this would be 16. This one. This is 16. This is 6 minus minus 6. This is 12. So therefore, all in all, this is going to be 28. Right? So this is going to be the definite integral. Okay? So number 44. Solve using calculator. In using calculator, you just have to be reminded how to do it in your calculator. So you just press integral. So this is going to be press the integral key. Then there are lower and upper limits. Then you have 12 alpha x x cubed. How do you input this in your calculator? This is going to be alpha close parenthesis. This is the x. For cube, this is shift x squared key. Okay? So this will be x cubed. Then plus 3 x squared. So to input x squared in your calculator, so you have alpha close parenthesis, this is the x, right? Then for the squared, you press x squared. Then plus 6x. X of course is alpha close parenthesis. Okay? And then plus 3. So then press your right arrow key. Your cursor will move to the lower limit. So the lower limit is minus 2. Then press the right arrow key. Your cursor will move to the upper limit. So this is 2, the upper limit. Then press equals. So it will process for a while. Then your calculator will display the answer. And the answer is 28. You follow? Okay. So what about this one? We are asked here to solve this manually. So again, this one is a binomial raised to a certain power. So we expand first. So the square of a binomial is the same as the square of the first, that is 2 squared, minus twice their product, 2 times x over 2. This is minus, to copy the middle sign, plus the square of the second, that is x over 2 squared, dx. We simplify first, so this is going to be integral from 3 to 5 of, this is 4, this and this will cancel, so minus 2x plus x squared. 2 squared is 1/4, 2 squared, so this is x squared over 4. So dx. This is now composed of independent powers of x. So integrating this, you'll get 4 integral of dx x minus 2 integral of x to the 1, that is x squared over 2, plus 1/4 integral of x squared x cubed over 3. we don't add constant of integration because there are limits. So from 3 to 5, we substitute the upper limit for x. 2 cancels here. So this is going to be 4 times 5 minus 5 squared plus 112. 4 times 3 is 12. X replaced by 5 cubed. Substitute the lower limit for x here. You have minus 4 times 3 minus 3 squared plus 112 3 cubed. Okay? So we now compute this. This is going to be 20 minus 25. This is, we just compute directly. No? So this is 109 over 6. Okay? So you compute this. This would be 1/6. You get it? So let us have number 46. Solve using calculator. Using calculator here will be straightforward. So this would be press the integral key, lower limit, upper limit. Then open parenthesis 2 minus x. X will be alpha, close parenthesis. Then divide by 2. You may press divide or the fraction key. Close parenthesis, then squared. Squared key is x squared. Okay? So I have it now here. So press the right arrow key for the lower limit. Press it 3. Right arrow key for the upper limit or upward arrow key. So press 5, then equals. Your calculator will display in no time the answer, which is 1/6. You follow? What about this one? So, the integral from 2 to 3 of dx over x times cube root of 8 times x. So, let us first simplify because this is a product of two expressions. So, let us combine them into one. So, this is the same as integral from 2 to 3 of dx over x cube root of 8 is 2. This is cube root of x is x to the 1/3. So, we further simplify. This is integral from 2 to 3 of dx over 2 x to the 1 times x to the 1/3. That is x to the 1 plus 1/3. That is 4/3. So, that is 1 plus 1/3. 1 plus 3 over 3. So, that is 4/3. Okay? So, make this as a numerator. So, this is going to be integral from 2 to 3 of 1/2. I factored out the 1 over 2. X to the minus 4/3 dx. I make this a numerator. So, then, I reverse the sign of the exponent. So, this time, this is now an independent power of x. We apply power formula. So, this is going to be 1/2. Integral of x to the minus 4/3 is x to the minus 4/3 plus 1. So, the shortcut is minus 4 plus 3 minus 1 over 3. That is minus 4/3 plus 1. That is minus 1/3 over minus 1/3. Okay? So, we don't add limits because we don't add constant of integration because there are limits. So, we evaluate this from 2 to 3. We simplify first. So, this is going to be minus of 3 over 2. That is minus 1.5 x to the minus 1/3. Or make this positive over x to the 1/3. Or this is the same as cube root of x. Okay? So, this is minus 1.5 over the cube root of x. That is from limits 2 to 3. Okay? So, we do it. So, you're going to have it as, we just factor out the minus 1.5, 1 over the cube root of, we substitute the upper limit, 3 minus 1 over the cube root of the lower limit, 2. You compute this and you'll get 0.15050888775. This will be your answer. You get it? Okay. Now, number 48. Solve using calculator. Okay? So, using our calculator, we will have this one as press the integral key. Then, so press the integral key, lower limit, upper limit. So, you have 1 over. So, press the fraction key. So, this time, you are in the denominator. So, alpha x, which is alpha, close parenthesis, this is your x, times cube root of, if it is multiplication of expressions, you don't need to write the times, no? So, cube root of 8x, that is cube root is shift square root. Shift square root is cube root. Okay? So, therefore, we are inside now. So, 8, we are inside this cube root. So, 8 alpha x. Alpha, close parenthesis. This is your x. Then, you press the right arrow key to get out of the cube root. Then, you press again the right arrow key to get out of the denominator. Then, you press right arrow key again to go to the lower limit. So, input the lower limit, 2. Then, press the right arrow key again to go to the upper limit. The upper limit is 3. Then, press equals. Your calculator will display the answer, and the answer is equal to, you'll get 0.15050888775. The answer will be exactly the same. You follow? What about this one? The integral of 4y plus 6 over y square root of y dy. So, take note that these are already independent powers of y. We just make this in the numerator. Okay? So, this is the same as integral from 1 to 5 of 4y plus 6 over y square root of y is y to the 1/2. So, this is the y. So, this is the same as integral from 1 to 5 of 4y plus 6 y times y to the 1/2 is 1 plus 1/2, 3/2. So, this is 6 over y to the 3/2 dy. We make this as an exponent by reversing the sign of the exponent. So, this is the same as integral from 1 to 5 of 4y plus 6 y to the minus 3/2 dy. So, we are ready to integrate this. Integrating that would be the same as 4 integral of y to the 1 is y to the 2 over 2 plus 6 integral of y to the minus 3/2, that is y to the minus 3/2 plus 1. The mathematical shortcut, minus 3 plus 2 minus 1 over 2. So, minus 3/2 plus 1 is minus 1/2 over minus 1/2 with limits from 1 to 5. Okay? I will be moving horizontally, ha? So, simplifying this is going to be 2y squared times 6, 12 over negative 1 minus 12 y to the minus 1/2 from 1 to 5. We substitute 5 for y. We have 2 times 5 squared minus 12, 5 to the minus 1/2 minus, we substitute the lower limit 1. So, you have 2 times 1 squared minus 12 times 1 to the minus 1/2. You calculate this and you'll get here 54.63. Do you follow? Okay. What about number 50? Solve using calculator. So as you can see, our calculator is limited if there are limits. Without the limits, we really need to do it manually. Okay? So in here, solving this using our calculator, this is the same as press the integral key, lower limit, upper limit. So open parenthesis for, there is no integral dy in your calculator. You just have integral dx. So this must be entered as x. So for alpha x is alpha close parenthesis, no? So plus 6 fraction key to make it or to bring it to the denominator. So alpha y, we are now in the denominator. So alpha y, that is alpha x is close parenthesis, okay? Then square root of, then we are here inside, so that is alpha x. So again, alpha x, y must be entered as x. So you press the right arrow key to get out of the square root, then you press the right arrow key to get out of the denominator, then you press the right arrow key again to go to the lower limit. Input the lower limit, that is 1. Right arrow key to go to the upper limit. Then press the upper limit, which is 5. Then press equals. Your calculator will display the answer. Rounded off, it is 54.63. Do you follow? Okay. So you just practice using your calculator and practice using manual computation. You follow?